Okay, so lesson 3 is on the cosine law. So remember, we are no longer using SOHCAHTOA. We are no longer going to see right triangles. So on your unit exam, expect 0 right triangles. You are not once going to ever try and use SOHCAHTOA. You're only going to use sine law and cosine law. So what's the cosine law? Well, let's look at this triangle here. Remember, for sine law, we need to know an angle and its opposite side to make that x. So notice here, I know angle 36, but I don't know its opposite side. I know side C, AC, or side little b, but I don't know its angle. And I know side C, but I don't know angle C. So we have a problem. Is there any way to figure out one of those angles? The answer is no. If we only know one is 36, we can't figure out any of the other ones because we're not dealing with a 90 degree in one of them. So unfortunately, the sine law won't work here because for us to use the sine law, we need to know an angle and its opposite side. So can we determine the length of BC right now? No, you don't have enough information. You don't have enough information. We need a different angle to use the sine law. We need a different angle to use the sine law. To use the sine law. So in the above example, we are going to give the length of two sides and the contained angle. The sine law is not applicable. So in that, whenever we know two sides and a contained angle, so an angle in between those two sides, then we cannot use the sine law. We have to use the cosine law. Now, example 1, I'm going to skip. It's basically constructing a right triangle, going through a whole bunch of calculations to get side BC, and that would take a longer time. So instead, we're going to go straight into the proof. So on the other page, again, remember how we label our triangles. So we label our triangles opposite of angle A, side A, and so forth. So in every triangle ABC, this is the cosine law, and this is on your formula sheet. So what does it look like? Well, it looks like it has some cosine ratios in it, and it also looks like Pythagorean theorem. So let's go through the proof. So let's read through it. The diagram shows triangle ABC placed with the base AB on the x-axis and A is on the origin. Remember, that's 0, 0. The line CD is drawn perpendicular to AB to make a right angle. And it's h units in length, so it's the height. Now, if AD is x, then this little guy, DB, right here, would be, if our full length, we call it C, right? That's C, because it's opposite of angle C, we would call this C minus x, C minus x. Okay, so let's go ahead. Well, let's look at cos of A. Cos of A, angle A. Remember, cosine ratio is your adjacent over your hypotenuse. So in this case, it would be x over b. And if you rearrange for x, we'd multiply both sides by b. And so x would equal to b cos A. B cos A. Notice we're getting somewhere. Somewhere, but not totally. Okay, next one. It says in triangle BDC. BDC. So they're looking at triangle BDC. That triangle right there. Well, with Pythagorean theorem, if we have a squared, it's equal to h squared times c minus x squared. So what they did here is they FOILed this out. So just on a side note, remember that c minus x, times c minus x is the same thing as c minus x squared, and then they FOILed it out to get this guy, and so forth. Okay, so that's where that came from. You don't have to prove this. I'm just showing you the proof. So rearranging this formula, let's go down through these steps. They rearrange and put h and the x together, and we move the c minus 2x, 2cx over here. So what happens over here? What is h squared plus x squared? Well, h squared plus x squared is actually the other triangle, another triangle. If you look up above, h squared plus x squared is equal to b squared, equals to b squared. So going down below, we're going to replace the h squared plus x squared with b squared. And we still have the c. The c went there. And then what is x equal to? What is x equal to? Well, we said x is equal to b cos A. And so that's where that's coming from. So we're going to write b cos A. And so that's where our full formula comes from. So you do not have to prove this, and it's a similar proof for the other two sides. You just have to change the formula. When do we use the cosine law? We use it for two sides in a contained angle. So let's look at this. We know angle A, this is little a. We know side C and side B, and we're looking for side BC, or little a. We can't use the sine law, so let's remember that the cosine law is a squared is equal to b squared plus c squared minus 2bc cos A. Okay, so when you're remaking your formula, notice that BC, BC, and if you're cos of your A, cos of A. So that's how the formula will always go. So let's plug in what we know. We know that b squared, well, what's side b? Side b is 6. So 6 squared plus c is 3 squared minus 2 times 6 times 3. Cos of angle A is 36 degrees. So in your calculator, type that in. Let's move this over here. So we have 6 squared plus 3 squared minus 2 times 6 times 3 times the cos of 36. Cos 36. There you are, cos 36. Now, 15.875. That's a lot larger than the other numbers. But let's write it down. A squared equals 15.87. Now, notice you have a square. So our last step is we have to square root both sides. So square rooting that answer. That's a common mistake because we forget to square root. And to the nearest tenth, that would be 4.0. 4.0. So A is equal to 4.0 centimeters. There you go. Okay, look at PQR. PQR. Okay, so let's label what we know. It says complete the cosine law for calculating side Q, if we're looking for little q. So if it's usually a squared is equal to b squared plus c squared minus 2bc cos of a. So if we're looking for q squared, it would be little r, little p. So the other two sides squared, p squared times plus r squared minus 2, notice how these were multiplied together, 2 times r times p, and cos of the angle we're looking for. So we're looking for a little side q, so it'll be cos q. So let's fill in what we know. We're looking for side q. They tell us that qp is 1.7, qr is 3.1, and angle PQR is 110 degrees. So we're set. We want to use the cosine law because we know two sides in a contained angle. Side, angle, side, right? Side, angle, side is when we use the cosine law. Cosine law. Side, angle, side. Okay, so we already made our formula above, which is q squared equals r squared plus p squared minus 2rp cos of q. So q squared is equal to r, little r is 1.7 squared plus little p is 3.1 squared minus 2 times 1.7 times 3.1 times the cos of our angle of 110 degrees. So plugging that into our calculators, we have 1.7 squared plus 3.1 squared minus 2 times 1.7 times 3.1, and cos of 110 degrees gives you 16.1 to the nearest tenth. 16.1. Now, q squared equals 16.1. Is that our final answer? No, we have to square root both sides. So second square root, second negative to get your answer. And to the nearest tenth, it's 4.0 centimeters. And there you go. Okay, so that's it for the first part of this lesson. I'm going to carry on. As far as the bearing questions, let's look at this one. So Bellevue is 30 kilometers north. So we have A, B, and C. So Bellevue is north, 30 kilometers north of Erie. So A, and Churchville is 18 kilometers northwest. So northwest, nobody eats soggy wieners. Northwest is this direction, right? So Churchville is 18 kilometers northwest. So that would be a 45-degree angle if you're exactly northwest. And there's Churchville. And it's 18 kilometers. So completing our triangle there, it says calculate the distance between Bellevue and Churchill to the nearest kilometer. So we want our opposite side x. Or we can call that little a even, because that's where angle A. So little a, we know B, and we know C. So again, our formula is a squared is equal to b squared plus c squared minus 2bc cos A. So a squared is 18 squared plus 30 squared minus 2 times 18 times 30 cos of 45 degrees. So plugging that in, 18 squared plus 30 squared minus 2 times 18 times 30 times the cos of 45 gives 460. We want to square root both sides, and therefore A is going to give us the nearest kilometer 21 kilometers away. Okay. So what do we do if we're looking for an angle? Well, we just rearrange our formula. How do we rearrange our formula? Well, if I'm looking for cos A, I'm just going to grab your formula sheets for a second. So on your formula sheet, it's already rearranged for you. So we could go through how to rearrange it, but to save time, we won't. So there it is. So what if I was looking for cos of B? Well, we just look at the order. If I was looking for cos A, it's the other two added together minus the side opposite of our given angle. So if I was looking for B squared, it would be A squared plus C squared minus B squared, and then divided by 2 times the same that 2 that you multiplied together in the begin with. So this it would be 2AC. So in this case, if we're looking for C, it would be A squared plus B squared minus C squared all over 2AB. Okay? So you have to know how to change the formula to work for your given triangle. And when would we use this? Well, when you know side, 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 and you want to look for an angle. That's when we use the cosine law. So no angle is given, and you want to find an angle, and you know 3 sides. So triangle ABC, they tell us A, B, C. Side A is 14.7, is little a. They tell us little b is 8.9. As you can see, my diagram is not to scale. And little c is 12.6. Determine the largest angle. Well, you could waste a lot of time figuring out all your angles, or you should know that opposite the largest side is always the largest angle. And so since 14.7 is the largest side, I want angle A. I want angle A. So cos of A is what we're looking for. So the formula would be b squared plus c squared minus a squared all over 2bc. Plug in cos of A is equal to, our b is 8.9 squared minus 12.6 is c, plus 12.6 squared minus a squared is 14.7 squared, all divided by 2 times 8.9 times 12.6. Now, where students make a mistake is punching this into their calculator. If we're going to punch this in all at once, remember you need invisi brackets around your numerator and denominator. You want to hold in your numerator and hold in your denominator. You don't want anything to fall off the sides. So we start with a bracket, 8.9 squared plus 12.6 squared minus 14.7 squared. Close your numerator. Divided by bracket, 2 times 8.9 times 12.6. Close your bracket, right? As long as you do that, you will be okay. So that should not alarm you. So I get cos A equals 0.975 or 0.976. 0.0976 is our cos of A. I look correctly? Yeah. And we're not done. So you expect to see a weird decimal because we want angle A, so we have to use inverse cos. Whenever you're looking for an angle, we use inverse. Second cos, second answer, and it gives me 84.4. 84.4. And we want the nearest degree would be 84 degrees. So the largest angle is 84 degrees. One more question. Two ships sail from port P heading in different directions. The first ship sails 7 kilometers to R and the second ship sails 8 kilometers to Q. If the distance between R and Q is 13 kilometers, determine the angle between the directions of the two ships. So we want angle P. So let's remember this would be little p, we have little r, and little q. If you want cos of p, so we're going to use cosine law because we have 3 sides. So cos of p is equal to the other 2 sides are added together, q squared plus r squared minus p squared over 2qr. Okay, so plugging that in, q squared was 7, so 7 squared plus 8 squared minus 13 squared over 2 times 7 times 8. Again, you don't want anything to fall off. Whenever we have more than one thing on our numerator denominator, we have to wrap it in brackets so they don't fall off. Bed math will get ya. So, bracket, 7 squared plus 8 squared minus 13 squared. Close the bracket, divided by, open another bracket, 2 times 7 times 8. Again, we expect a decimal. So I get cos of p equals negative 0.5. Don't be alarmed by the negative. And so we want our angle p. What do we use? We use inverse of our ratio. We're getting a negative when it's greater than 90 degrees, so don't let that alarm you. So second cos of negative a half gives you 120 degrees. So last, we should probably write a statement. Therefore, the ship sailed, or the angle between the two ships, angle between the directions of the ships, of the two ships, is 120 degrees. All right, and that's it.